Hey everybody, in this video I'm going to show you how to convert a Landsat image into a Reflectance image using the SCP plugin in QGIS. I did not invent the SCP plugin, far from it. I learned how to use it earlier today, and it's really awesome, and you can actually donate money to the creator of the SCP to help further development of this awesome tool, and I recommend that you do that. This video is going to assume you know a lot. If you need to know about the basics of Landsat, how to load an image into QGIS, go here. If you need to understand a bit about radiometric resolution and how images are measured, go here. And if you want to understand the theory behind converting radiance into reflectance, go here. If none of this sounds familiar, I definitely recommend you watch some of these videos. So prior to this video, what I did, I downloaded a Landsat image of Lake Champlain from 1999. And that's going to be here in my tutorial folder. If you're in my class, you should have copied this Lab 4 folder onto your hard drive and unzipped it, and you'll find this tutorial folder. Within here, we've got a Landsat folder. So take a look at this. Inside this Landsat folder, we have one file for each of the bands. And you can tell which band is which because with the number that it ends on. So here, NN80, that's band 8, NN10, that's band 1, NN20, that's band 2, and so on. So we've got these Landsat bands in here. We've also got this file, which is a text file, and that is the metadata file that came with the Landsat. That's a text file. I won't bother to open it. Well, I guess I will bother to open it because it's actually kind of relevant. So quickly, we'll look in here. It has all this information. Landsat 7, collected in 1999, and then lots of information about the sensor, okay? And what's cool about the SCP is it's going to pull all this information right out of the metadata for us. Okay, so just wanted you to see that folder. So now let's go into QGIS. Here's the image. This is a virtual raster rendered as a true color image. And what we're going to do in this video is use the SCP plugin. So to do that, if you haven't already, you need to go to Plugins, Manage and Install, and actually activate the SCP plugin. Once you do that, you should see this SCP icon here. I usually go down and I just use the Show plugin. And what that does, it brings up this SCP doc on the side, which is pretty cool. And in this video, we're going to start by using this part of it, this stacked layer. And we're going to use specifically today the pre-processing tools. So it's important to know SCP is designed to do really powerful image classification, but today we're actually just going to use the one of the pre-processing tools to convert our image from digital numbers into reflectance. All right, so we'll click on that pre-processing. So now the cool thing about this is as long as your Landsat's bands are all in the same folder, you can just go here. You can tell it which folder they're all in. Okay, in this case it's Tutorial Landsat. Select that, and boom, it brings them all up here in this list down here. And then also you can select the MTL file. That's the metadata file. Sometimes for newer ones it'll find this automatically. It'll look for a text file with the letters MTL in the name. So it may have already found this if you're using a newer Landsat image. If not, you can actually go and prompt it and tell it which file is the metadata. So in this case, it's going to be the text file here. It doesn't have the letters MTL, but I know it is the metadata. We just saw it. So I'm going to open that. And the cool thing, if you successfully connect it with the metadata file, it will read out all the radiometric parameters of your Landsat image. And it will also read out the date. So check this out. It's now populated. The satellite is Landsat 7. Date of the image collection, the sun elevation, and the Earth-Sun distance. And if you've watched our video on converting to reflectance, you know these are some parameters that we need to compute radiance into reflectance. If you've watched our video on digital numbers in radiometric resolution, you will also know that you will need numbers like this, L max, L min. Those are the max and min radiance collected by the sensor in each band. And then here's the max and min digital number to which those were encoded. So from that, you can compute the gain and the radiometric response function. So the cool thing about this SCP plugin is it does all this for you. It went and grabbed it all out of the metadata. So in our case, we do not want to work with all of the data. You may know that, for example, band 6 of the Landsat is a 60-meter resolution. It's a thermal band. So we're not going to use that here. So I'm going to hold down Shift, highlight both of these rows for the two band 6s, and just hit this subtraction sign, and we'll remove those. We are going to keep, actually, we're going to get rid of band 8 too. Band 8 is the panchromatic band. It's a 15-meter resolution, so we don't want to work with that either. So I'm going to delete that row. All right, so that leaves us with band 1, 2, 3, 4, 5, 7. It's always good practice to make sure these are stacked in the correct order. So 1 is at the top, then 2, then 3, and so on. And in fact, you should probably pause right now and just jot down the order that they're in. Make a note that you're missing band 6, for example. It goes 1, 2, 3, 4, 5, 7. Always want to be keeping track of that order. Okay, so there they are. And we've got a bunch of options up here. So essentially, what's going to happen when we hit run, this thing by default is going to spit out a reflectance, a set of reflectance images. There's an option if you want to do a brightness temperature. We're going to do that later in the course. There's an option here if you want to apply dark object subtraction, atmospheric correction. If you want to know what that is, see the video, previous video on radiance to reflectance. Here, apply only to blue and green bands. That makes sense because those are the shortest wavelength, so you tend to have the most atmospheric reflectance in the atmospheric contamination in the blue and green bands, and you have a lot less in your thermal bands. So we're going to leave it there. We're only going to do blue and green, dark object subtraction correction, and we are going to create a band set here. So we're basically going to leave these all at the defaults, but it's worth seeing what they are. All right, so now we'll hit run, and it's going to prompt us for a folder. So here we do have a tutorial output folder. You can put it wherever you want, but in here I'm going to call this, call it 1999 Landsat Reflectance. So I'm making a whole folder. It's going to store all the images in that folder, and it's probably going to give them, it's going to add on a little root name to them. So we'll hit, oh, it's already going. We'll pause while it does this and come back when it's done. Okay, so it finished, and it added the various reflectance layers over here. Of course, those have also now shown up in your folder, your output folder over here. And if you want, you can create a virtual raster layer of them, but we don't need to, because now we're headed to extract spectral signatures in the next video, and we won't need to create a virtual raster layer to do that. Thanks for listening.